Students, will go to the next topic, that is law of conservation of energy. Now, according to this law, energy can be only converted from one form to another form. Okay, it can neither be created nor be destroyed. The total energy before and after transformation always remains the same. So you can neither make energy nor you can destroy it. So in the entire universe, the energy remains same. Okay. Now, the law of conservation of energy is valid in all the situations and all kinds of transformations. Okay. Now, for example, we have got kinetic energy. It would be the largest and the potential energy will be the least. Okay. When you are transforming the energy from potential to kinetic, then the sum of this potential energy and kinetic energy would be same at all the points. Whether this increases or this will decrease. If this decreases, this will increase. When you add both of them, it will remain the same. But when we add potential energy plus kinetic energy, potential energy is mgh, kinetic energy is half mv square. It will be always same. It will be always constant. Now the sum of this kinetic energy and potential energy is known as total mechanical energy. It's known as a total mechanical energy. So mechanical energy is potential energy plus kinetic energy. Okay. Now if this potential energy is gravitational, so in place of gravitational, whenever there is gravitation, the gravitational potential energy into kinetic energy whenever you are lifting a substance. Okay, so the potential energy becomes gravitational potential energy. Now we go to the next topic, that is rate of doing work. Okay, now all of us do work, but the rate of doing work depends on individual person or depends on what machines we are using. Okay, so for example, a stronger person may do the certain work at relatively less time. It take little bit less time to complete the work. A more powerful vehicle will complete the journey in shorter time than the less powerful one. So when more strong, less time. Okay, so this all time and energy, they are independent of, they are dependent on each other. So energy and time, you have got a new quantity known as power. Now what does this power do? It measures the speed of the work done, that is how fast or slow the work is done. Now this power is defined as the rate of doing work or the rate of energy transfer. Okay, so now here the definition of power becomes work upon time. So work done in time. Okay, so W upon T, this is the formula of power. The unit of power is watt, in honor of the scientist James Watt. Okay, now what is 1 watt? 1 watt will be 1 joule per second. 1 joule is, that is the unit of work, and second is the unit of time. Okay, now that is equal to 1 watt. So 1 joule per second, so you can also write it like this, that is equal to 1 watt. Now there are another larger units of energy. For example, you have got kilowatt. Kilowatt means 1000 watts. Okay, now this kilowatts also you can write it as 1000 joules per second. Now we have got two examples. Example 11.7. I want everybody reading these examples properly and then go for the solution. Okay. Now in the solution part, we have got two girls here, girl A and girl B. Both of their weights are given in terms of Newton and the height is given. And we have to see whose power is more. Okay. Now the weight of the girl, that is the first girl, is 400 newtons and the height is 8. Now energy is equal to work done. We have got mg and h, so we can find out the potential energy mgh. Now this energy is equal to the work done. Just turn the page. So we just put the value of mgh, that is 400 newtons into 8 meters, and for power you have to divide it by time, that is 20 seconds. So you get 160 watts. Similarly for girl B, again you have to do mgh, that is 400 newtons into 8 meters. But the time taken here is 20 seconds and for the girl B it is 50 seconds. So the difference is in time. So here it is 160 watts and here it is 64 watts. Now we go to the next example 11.8. Here we have got a boy whose mass is given 50 kg. Steps are given 45 steps in 9 seconds and the height of each step is given 15 centimeter. And we have to take g as 10 meter per second. So for calculating the weight, we have to multiply m into g, that is 50 kg into 10 meter per second, that is m into g, you will get 500 newtons. This will be the weight. Height is 45 stairs. Now this 45 stairs or 45 steps he covers in 15 centimeter. Each step is of 15 centimeters. So 45 into 50. Because it is given in centimeter, we have to convert it into meter, so divide by 100. So 45 multiplied by 15 divided by 100. We get 6.75 meters. So total, how much distance he has covered? 6.75. Because there are 45 steps and each step is of 15 centimeter. Centimeter we are converting into meter. Now how much time he takes to climb this? That is 9 seconds. Okay. So the work done will be 500 into 6.75 divided by 9. So that will be 375 volts. Okay. Now we have got the next topic. That is the last topic, that is commercial unit of energy. Whatever right now we are using the unit of energy, that just joules per second is a very small unit. So we have to use a bigger unit, that is kilowatt hour. Okay. Now what is this kilowatt hour? Kilowatt hour will be 1 kilowatt multiplied by 1 watt. Now we know that 1 kilowatt is equal to 100 watts. We have already seen in the previous page here. See, 1 kilowatt is equal to 100 joules, or 1 kilowatt is equal to 1000 joules or 1000 watts. Okay. So we take it here as 1000 watts. 1 hour is equal to 3600 seconds. So multiply them, both of them, you get 36 in 5 zeros. That is 36 into 10 raised to 5 joules. Now if I want to convert this into 10 raised to 6 joules, so I have to multiply one more 10. Because I am multiplying with 10, I have to also divide by 10 so that this value does not change. So it will become here 10 raised to 6 and 36 divided by 10, it will become 3.6. So how did this 3.6 into 10 raised to 6 came from 36 into 10 raised to 5? You multiply by 10 and divide by 10. So this value does not change. Both these answers are same. You can also write 36 into 10 raised to 5. You can also write 3.6 into 10 raised to 6. Okay. Now based on this, you have one more example 11.9. You have an electric bulb of 60 watts. Now 60 watts you have to convert into kilowatt. So 1 kilowatt is equal to 1000 watts. So 60 watts is equal to how much? So 60 upon 1000, that is 0.06 kilowatt. Time is 6 hours. So power into time, that is this much, you will get the energy. Okay, because power is equal to W upon T. So therefore W will be P into T. That is what they have done here. So you get 0.36 units. Thank you.